CIET and CERT presents audiobook Ganit Prakash, textbook of mathematics for grade 7.
Chapter 5 Parallel and Intersecting Lines. Page number 106. On the right side of the page, there is a QR code, scanning which you can reach out to the additional resources. 5.1 Across the line. Take a piece of square paper and fold it in different ways. Now, on the creases formed by the folds, draw lines using a pencil and a scale. You will notice different lines on the paper. Take any pair of lines and observe their relationship with each other. Do they meet? If they do not meet within the paper, do you think they would meet if they were extended beyond the paper? Figure 5.1. Here we have a picture in which the creases are represented by dotted lines. In this chapter, we will explore the relationship between lines on a plane surface. The tabletop, your piece of paper, the blackboard, and the bulletin board are all examples of plane surfaces. Let us observe a pair of lines that meet each other. You will notice that they meet at a point. When a pair of lines meet each other at a point on the plane surface, we say that the lines intersect each other. Let us observe what happens when two lines intersect. How many angles do they form? In figure 5.2, where line L intersects line M, we observe that 4 angles are formed. Page number 107. Here we have figure 5.2, in which two lines are intersecting, lines L and M, and they form angles A, B, C and D. Can two straight lines intersect at more than one point? Activity 1. Draw two lines on a plain sheet of paper so that they intersect. Measure the 4 angles formed with a protractor. Draw 4 such pairs of intersecting lines and measure the angles formed at the points of intersection. What patterns do you observe among these angles? In figure 5.2, if angle A is 120 degrees, can you figure out the measurements of angle B, angle C and angle D without drawing and measuring them? We know that angle A and angle B together measure 180 degrees because when they are combined, they form a straight angle which measures 180 degrees. So, if angle A is 120 degrees, then angle B must be 60 degrees. Similarly, angle B and angle C together measure 180 degrees. So, if angle B is 60 degrees, then angle C must be 120 degrees. And angle C and angle D together measure 180 degrees. So, if angle C is 120 degrees, then angle D must be 60 degrees. Therefore, in figure 5.2, angle A and angle C measure 120 degrees and angle B and angle D measure 60 degrees. When two lines intersect each other and form 4 angles labeled A, B, C and D as in figure 5.2, then angle A and angle C are equal and angle B and angle D are equal. Is this always true for any pair of intersecting lines? Check this for different measures of angle A. Using these measurements, can you reason whether this property holds true for any measure of angle A? We can generalize our reasoning for figure 5.2 without assuming the values of angle A. Since straight angles measure 180 degrees, we must have angle A plus angle B is equal to angle A plus angle D, that is equal to 180 degrees. Hence, angle B and angle D are always equal. Similarly, angle B plus angle A is equal to angle B plus angle C is equal to 180 degrees. So, angle A and angle C must be equal. Adjacent angles like angle A and angle B formed by two lines intersecting each other are called linear pairs. Linear pairs always add up to 180 degrees. Page number 108. Opposite angles like angle B and angle D formed by two lines intersecting each other are called vertically opposite angles. Vertically opposite angles are always equal to each other. From the above reasoning, we conclude that whenever two lines intersect, vertically opposite angles are equal. Such a justification is called a proof in mathematics. Figure it out. List all the linear pairs and vertically opposite angles you observe in figure 5.3. Here we are given a figure in which two intersecting lines L and M form angles A, B, C and D. We are also given a tabular column in which we have two columns, one with linear pairs as angle A and angle B, and the other one with pairs of vertically opposite angles, angle B and angle D. Measurements and geometry. You might have noticed that when you measure linear pairs, sometimes they may not add up to 180 degrees. Or when you measure vertically opposite angles, they may be unequal sometimes. What are the reasons for this? There could be different reasons. Measurement errors because of improper use of measuring instruments, in this case a protractor. Variation in the thickness of the lines drawn. The ideal line in geometry does not have any thickness, but it is not possible for us to draw lines without any thickness. In geometry, we create ideal versions of lines and other shapes we see around us and analyze the relationships between them. For example, we know that the angle formed by a straight line is 180 degrees. So, if another line divides the angle into two parts, both parts should add up to 180 degrees. We arrive at this simply through reasoning and not by measurement. When we measure, it might not be exactly so for the reasons mentioned here. Still, the measurements come out very close to what we predict, because of which geometry finds widespread application in different disciplines such as physics, art, engineering, and architecture. 5.2 Perpendicular lines. Can you draw a pair of intersecting lines such that all four angles are equal? Can you figure out what will be the measure of each angle? Page number 109. Figure 5.4. Here there is an image of two intersecting lines L and M such that they are perpendicular to each other. If two lines intersect and all four angles are equal, then each angle must be a right angle, that is 90 degrees. Perpendicular lines are a pair of lines which intersect each other at right angles, that is 90 degrees. In figure 5.4, we can say that lines L and M are perpendicular to each other. 5.3 Between lines. Observe figure 5.5 and describe the way the line segments meet or cross each other in each case with appropriate mathematical words like a point, comma, an endpoint, comma, the midpoint, comma, meet, comma, intersect, and the degree measure of each angle. For example, the line segments FG and FH meet at the endpoint F at an angle 115.3 degrees. Here in figure 5.5, we have different type of lines. We have ST parallel to UV, OP parallel to QR, and intersecting lines AB with CD. They intersect at X. Line IJ and ML intersect at Y, and angle HFG with angle of 115.3 degrees. Are line segments ST and UV likely to meet if they are extended? Are line segments OP and QR likely to meet if they are extended? Here are some examples of lines we notice around us. Page number 110. Here we have beautiful images of piano, a bench, and a railway track depicting parallel lines. All these examples are from daily life situations. What is common to the lines in the pictures above? They do not seem likely to intersect each other. Such lines are called parallel lines. Parallel lines are a pair of lines that lie on the same plane and do not meet however far we extend them at both ends. Name some parallel lines you can spot in your classroom. Here we have two images in which we can observe parallel lines. One is from the Rangoli design and the other one is a artwork in which parallel lines can be observed. Parallel lines are often used in artwork and shading. Which pair of lines appear to be parallel in figure 5.6 given here? Here we have a picture in which dotted points are used to draw intersecting lines, parallel lines, and perpendicular lines. Lines are A, B, C, D, E, F, G, H, and I. Note to the teacher. Is it important that the lines lie on the same plane? A line drawn on a table and a line drawn on the board may never meet, but that does not make them parallel. Page number 111. 5.4 Parallel and perpendicular lines in paper folding. Activity 2. Take a plain square sheet of paper. Use a newspaper for this activity. How would you describe the opposite edges of the sheet? They are dashed to each other. How would you describe the adjacent edges of the sheet? The adjacent edges are dashed to each other. They meet at a point. They form right angles. Fold the sheet horizontally in half. A new line is formed. See figure 5.7. How many parallel lines do you see now? How does the new line segment relate to the vertical sides? Here we have in figure 5.7 paper folding activity in which the paper is folded in a horizontal way which divides the paper into two equal parts. Again, the paper is refolded and now you can find that it is divided into four equal parts showing parallel lines. Again, we repeat the step and we see that on folding it horizontally, we get 8 parallel lines. Now, we fold the paper in a vertical way. To find that, we have vertical fold dividing those parallel lines, and this vertical line is perpendicular to all these parallel lines. Make one more horizontal fold in the folded sheet. How many parallel lines do you see now? What will happen if you do it once more? How many parallel lines will you get? Is there a pattern? Check if the pattern extends further if you make another horizontal fold. Make a vertical fold in the square sheet. This new vertical line is dashed to the previous horizontal lines. Fold the sheet along a diagonal. Can you find a fold that creates a line parallel to the diagonal line? Page number 112. Here is another activity for you to try. Take a square sheet of paper, fold it in the middle and unfold it. Fold the edges towards the center line and unfold them. Fold the top right and bottom left corners onto the creased line to create triangles. Refer to figure 5.8. The triangles should not cross the crease lines. R, A, B and C parallel to P, Q and R respectively? Why or why not? Here in the figure 5.8, a paper is being represented by folding it vertically. Again, in the next step, we are refolding the paper in the vertical line and we get 4 parallel lines. In the next, we have paper folded in the form of triangles with edges A, B and C and P, Q and R. Notations. In mathematics, we use an arrow mark to show that a set of lines is parallel. If there is more than one set of parallel lines, as in figure 5.9, the second set is shown with 2 arrow marks and so on. Perpendicular lines are marked with a square angle between them. In figure 5.9, we have set of parallel lines with arrows marked on it, and another figure with two parallel lines intersected by two other parallel lines with double arrow marks. In another picture, we have two perpendicular lines with 90 degrees marked between them. Page number 113. Figure it out. Question number 1. Draw some lines perpendicular to the lines given on the dot paper in figure 5.10. In the picture, we have figure 5.10 in which some dotted lines are joined, some are intersecting, and some will be perpendicular on extending them. Question number 2. In figure 5.11, mark the parallel lines using the notation given above with single arrow, comma double arrow, etc. Mark the angle between perpendicular lines with a square symbol. A. How did you spot the perpendicular lines? B. How did you spot the parallel lines? In figure 5.11, we have different pictures in which we can explore parallel lines and perpendicular lines. Question number 3. In a dot paper following, draw different sets of parallel lines. The line segments can be of different lengths but should have dots as endpoints. Page number 114. Question number 4. Using your sense of how parallel lines look, try to draw lines parallel to the line segments on this dot paper. Here in figure 5.12, we have a dot paper in which we can find various lines: lines A, line B, line C, line D, line E, line F, line G, line H, which have been joined by using 2 dots, 3 dots, 4 dots, 5 dots, and so on. A. Did you find it challenging to draw some of them? B. Which ones? C. How did you do it? Question number 5. In figure 5.13, which line is parallel to line A, line B, or line C? How do you decide this? In figure 5.13, we have a line which is formed by joining 2 dots. Line B is parallel to line A, and there's another line which is between 2 points as line C. Note to the teacher: it is easier to draw vertical and horizontal lines and the ones inclined at 45 degrees on rectangular dot sheets. But drawing a line parallel to one which has a different orientation is slightly harder. Let students use their intuition for this. From previous exercises, we observed that sometimes it is difficult to be sure whether two lines are parallel. To determine this, we use the idea of transversals. Page number 115. 5.5 Transversals. We observed what happens when two lines intersect in different ways. Let us explore what happens when one line intersects two different lines. Here, in figure 5.14, we have two intersecting lines L and M, which are cut by a transversal, and 8 angles are represented in the figure. Angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. The transversal is T. In figure 5.14, line T intersects line L and M. T is called a transversal. Notice that 8 angles are formed when a line crosses a pair of lines. Is it possible for all the 8 angles to have different measurements? Why? Why not? What about 5 different angles? 6, 5, 4, 3, and 2. In figure 5.14, since angle 1 and angle 3 are vertically opposite angles, they are equal. Are there other pairs of vertically opposite angles? We can see that there are a total of 4 pairs of vertically opposite angles, and in each pair, the angles are equal to each other. Thus, when a transversal intersects two lines, it forms 8 angles with a maximum of 4 distinct angle measures. 5.6 corresponding angles. In figure 5.14, we notice that the transversal T forms two sets of angles, one with line L and another with line M. There are angles in the first set that corresponds to angles in the second set based on their position. Angle 1 and angle 5 are called corresponding angles. Similarly, angle 2 and angle 6, angle 3 and angle 7, angle 4 and angle 8 are the corresponding angles formed when transversal T intersects lines L and M. Activity 3. Draw a pair of lines and a transversal such that they form two distinct angles. Page number 116. Step 1. Draw a line L and a transversal T intersecting it at point X. Here we can find a picture 5.15 in which line L is cut by a transversal T at point X. Step 2. Measure angle A formed by lines L and T. Let us say it is 60 degrees. Here in figure 5.16, we can find line L which is cut by a transversal T at point X, and it forms an angle A that is equal to 60 degrees. How many distinct angles have formed now? If one angle is 60 degrees, the other angle of the linear pair should be 120 degrees. So, we already have two distinct angles. So, when we draw another line intersecting the transversal T, we wish to form only two angles, 60 degrees and 120 degrees. Step 3. Mark a point Y on line T. Here we find a picture, figure 5.17, in which line L is cut by a transversal at point X with angle A is equal to 60 degrees and a point Y on transversal T. Step 4. Draw a line M through point Y that forms a 60 degrees angle to line T. This can be done either by copying angle A with a tracing paper, or you can use a protractor to measure the angles. In figure 5.18, we find two parallel lines L and M which are cut by a transversal T at points X and Y, and angle A and angle B each is of degree 60 degrees. What do you observe about lines L and M? Do they appear to be parallel to each other? Yes, they do appear to be parallel to each other. Angles, angle A and angle B, are corresponding angles formed by the transversal T on lines L and M. These corresponding angles are equal to each other. Page number 117. From this, we can observe when the corresponding angles formed by a transversal on a pair of lines are equal to each other, then the pair of lines are parallel to each other. Suppose we have a transversal intersecting two parallel lines. What can be said about the corresponding angles? Activity 4. Figure 5.19 has a pair of parallel lines L and M. What is the notation used in the figure to indicate they are parallel? Line T is the transversal across these two lines. Angle A and angle B are corresponding angles. Take a tracing paper and trace angle A on it. Now, place this tracing paper over angle B and see if the angles align exactly. You will observe that the angles match. Check the other corresponding angles in the figure using a protractor. Are all the corresponding angles equal to each other? Here we have figure 5.19 in which we can find line L and M to be parallel lines which are cut by a transversal T with two corresponding angles, angle A and angle B, to be equal. Corresponding angles formed by a transversal intersecting a pair of parallel lines are always equal to each other. Activity 5. In figure 5.20, draw a transversal T to the lines L and M such that one pair of corresponding angles is equal. You can measure the angles with a protractor. Here we have in figure 5.20 lines L and line M which are not parallel to each other. Are you finding it hard to draw a transversal such that the corresponding angles are equal? Page number 118. When a pair of lines are not parallel to each other, the corresponding angles formed by a transversal can never be equal to each other. 5.7. Drawing parallel lines. Can you draw a pair of parallel lines using a ruler and a set square? Figure 5.21 shows how you can do it. Draw a line L with a scale. By sliding your set square, you can make two lines perpendicular to line L. Are these two lines parallel to each other? How are we sure that they are parallel to each other? What angles are formed between these lines and line L? Here we have figure 5.21, in which we can find a scale and a set square which is sliding and forming parallel lines. Since we used a set square, the angles measure 90 degrees. The position of the line is different, but they make the same angle with L. If line L is seen as a transversal to the two new lines, then the corresponding angles measure 90 degrees. Here we have in figure 5.22 a scale and a set square which is forming a pair of parallel lines. As we know, these are corresponding angles and they are equal, we can be sure that the lines are parallel. Draw two more parallel lines using the long side of the set square as displayed in the figure 5.22. Page number 119. How do you know these two lines are parallel? Can you check if the corresponding angles are equal? Note to the teacher. Students should be encouraged to check the equality of corresponding angles both by using the tracing method and using protractors to measure the angles. Pay attention to the language used to make the relationship between corresponding angles and parallel lines. Equality of corresponding angles is both necessary and sufficient for the pair of lines to be parallel to each other. Figure it out. Can you draw a line parallel to L that goes through point A? How will you do it? With the tools from your geometry box. Describe your method. Here we have figure 5.23 with a line L and point A which is marked little away from it. Making parallel lines through paper folding. Let us try to do the same with paper folding. For a line L given as a crease, how do we make a line parallel to L such that it passes through point A? We know how to fold a piece of paper to get a line perpendicular to L. Now try to fold a perpendicular to L such that it passes through point A. Let us call this new crease T. Now fold a line perpendicular to T passing through A again. Let us call this line M. The lines L and M are parallel to each other. Here we have figure 5.24 depicting the paper folding method. In the first one, the paper is folded horizontally and that crease represents line L. And there's a point A marked on the right side of the paper. Now, in the third picture, the paper is folded vertically across the point A to form a perpendicular that is 90 degrees with line L. In the fourth picture, we find with a fold parallel to line L and passing through point A. So, line L and M are parallel to each other and perpendicular to line T. Page number 120. Why are lines L and M parallel to each other? 5.8 alternate angles. In figure 5.25, angle D is called the alternate angle of angle F, and angle C is the alternate angle of angle E. Here we have figure 5.25 in which line L and M are parallel to each other and a transversal T cuts these two parallel lines to form angles angle A, B, C, D, E, F, G and H. You can find the alternate angle of a given angle, say angle F, by first finding the corresponding angle of angle F, which is angle B, and then finding the vertically opposite angle of angle B, which is angle D. Activity 6. In figure 5.25, if angle F is 120 degrees, what is the measure of its alternate angle, angle D? We can find the measure of angle D if we know angle B because they are vertically opposite angles. Remember, vertically opposite angles are equal. What is the measure of angle B? It is 120 degrees because it is the corresponding angle of angle F. So, angle D also measures 120 degrees. In fact, angle F is equal to angle B irrespective of the measure of angle F. Why? Because angle B is the corresponding angle of angle F. Similarly, angle B is equal to angle D irrespective of the measure of angle B. Why? Because angle D is the vertically opposite angles of angle B. So, it must always be the case that angle F is equal to angle D. Using our understanding of corresponding angles without any measurements, we have justified that alternate angles are always equal. Alternate angles formed by a transversal intersecting a pair of parallel lines are always equal to each other. Example 1. In figure 5.26, parallel lines L and M are intersected by the transversal T. If angle 6 is 135 degrees, what are the measures of the other angles? Page number 121. Here we have figure 5.26 in which lines L and M are parallel to each other, which are cut by transversal T, forming angles 1, 2, 3, 4, 5, 6, 7 and 8. Also with measure of angle 6 as 135 degrees. Solution. Angle 6 is 135 degrees. So, angle 2 is also 135 degrees because it is the corresponding angle of angle 6 and the lines L and M are parallel. Angle 8 is 135 degrees because it is the vertically opposite angle of angle 6. Angle 4 is 135 degrees because it is the corresponding angle of angle 8. Angle 2 is 135 degrees because it is the vertically opposite angle of angle 4. So, angle 2, angle 4, angle 6 and angle 8 are all 135 degrees. Angle 5 and angle 6 are a linear pair. Together they form 180 degrees. If angle 6 is 135 degrees, then angle 5 is equal to 180 minus 135, that is equal to 45 degrees. We can similarly find out that angle 1, angle 3 and angle 7 measure 45 degrees. Example 2. In figure 5.27, lines L and M are intersected by the transversal T. If angle A is 120 degrees and angle F is 70 degrees, are lines L and M parallel to each other? Here we have figure 5.27 in which lines L and M are intersected by transversal T and forming angles A, B, C, D, E, F, G and H. Also, angle A is marked as 120 degrees and angle F is marked as 70 degrees. Solution: angle A is 120 degrees, so angle B is 60 degrees because angle A and angle B form a linear pair. Angle B is a corresponding angle of angle F. If L and M are parallel, angle B should be equal to angle F. However, they are not equal. Therefore, lines L and M are not parallel to each other as the corresponding angles formed by the transversal T are not equal to each other. Example 3. In figure 5.28, parallel lines L and M are intersected by the transversal T. If angle 3 is 50 degrees, what is the measure of angle 6? Here in figure 5.28, we have lines L and M which are parallel and are cut by a transversal T with angles marked as angle 1, 2, 3, 4, 5, 6, 7, 8 and angle 3 is marked as 50 degrees. Page number 122. Solution: angle 3 is 50 degrees, therefore angle 2 is 130 degrees because angle 2 and angle 3 form a linear pair and linear pairs always add up to 180 degrees. Angle 2 and angle 6 are corresponding angles and they need to be equal since lines L and M are parallel. So, angle 6 is 130 degrees. Angle 3 and angle 6 are called interior angles. Is there a relation between angle 3 and angle 6? You could try to find the relationship by taking different values for angle 3 and see what angle 6 is. Once you find a relation, try to justify it or prove that this relation holds always. You will find that the sum of the interior angles on the same side of the transversal always adds up to 180 degrees. Example 4. In figure 5.29, line segment AB is parallel to CD and AD is parallel to BC. Angle DAC is 65 degrees and angle ADC is 60 degrees. What are the measures of angles? Angle CAB, angle ABC, and angle BCD. Solution. Let us observe the parallel lines AB and CD. AD is a transversal of these two lines. Here we have figure 5.29, in which we can find lines AB and DC to be parallel. Likewise, lines AD and BC to be parallel with a transversal AC, and the angles formed by these lines, angle DAC is marked as 65 degrees and angle ADC is marked as 60 degrees. We know that the sum of the interior angles formed by a transversal on a pair of parallel lines adds up to 180 degrees. So, angle ADC plus angle DAB is equal to 180 degrees. 60 degrees plus angle DAB is equal to 180 degrees. So, angle DAB is equal to 120 degrees. Can we find angle CAB from this? Angle DAB is equal to angle DAC plus angle CAB. So, 120 degrees is equal to 65 degrees plus angle CAB. So, angle CAB is equal to 55 degrees. Let us observe the parallel line segments AD and BC. They are intersected by a transversal CD. So, angle ADC plus angle BCD is equal to 180 degrees because they are interior angles on the same side of the transversal. Since angle ADC is given as 60 degrees, angle BCD is equal to 120 degrees. Similarly, we find angle ABC is equal to 60 degrees. Therefore, in figure 5.29, angle CAB is equal to 55 degrees, angle ABC is equal to 60 degrees, and angle BCD is equal to 120 degrees. Page number 123. Figure it out. Question number 1. Find the angles marked here. We have in figure 5.30 various images of parallel lines intersected by transversals. In the first case, angle A we are supposed to find out, and angle 48 degrees is represented between the parallel line and transversal. Likewise, angle B in the next image we need to find out when one of the angles formed by the parallel lines and transversal is 52 degrees. In the third one, we need to find out angle C, in which the angles marked are 99 degrees and 81 degrees, forming a linear pair, and we are supposed to find out angle C cut by a transversal. In the next, we need to find out angle D, where angle 81 degrees and 99 degrees forms a linear pair, and we are supposed to find out the angle between parallel lines and transversal, which is marked as angle D. In the next one, we need to find out angle E, where a pair of parallel lines is cut by two intersecting lines, and it forms various pairs of angles as 97 degrees and 83 degrees, and with the other transversal angle marked are 69 degrees, and we need to find out the measure of angle E. In the sixth case, that is angle F, we need to find out where two parallel lines are cut by a transversal and one of the angle is marked as 132 degrees and we need to find out angle F. In G, we need to find out the value of angle G when two parallel lines are cut by a transversal. Here, pair of vertically opposite angles are represented by angle measure 122 degrees and another set with angles 58 degrees. And we need to find out measure of angle G. In the next case, we have two parallel lines cut by two intersecting transversals. With one transversal, the angle formed is 120 degrees and with the other transversal, one of the interior angles formed is 75 degrees and we need to find out the alternate angle, that is angle H. In the next figure, we have two parallel lines cut by a transversal in which we find sum of three angles 70 degrees, 54 degrees and 56 degrees adding up to 180 degrees forming a straight line, and we need to find out the measure of angle I. And in the last picture, we have three parallel lines cut by two intersecting transversals forming angles 97 degrees, 27 degrees and 124 degrees. And we need to find one of the interior angles, angle J. Page number 124. Question number 2. Find the angle represented by A. In figure 5.31, we have four different situations. In the first one, lines are parallel, cut by two intersecting transversals with angles marked as A degrees, 100 degrees and 42 degrees. We need to find out the measure of angle A. In the next one, we have two parallel lines cut by another set of parallel lines and one of the angles marked is 62 degrees and we need to find out the measure of angle A. In the next picture, we have three parallel lines cut by one perpendicular line and another intersecting lines. And we have angles as 110 degrees, 35 degrees and we need to find measure of angle A. And in the last situation, we have again a set of parallel lines cut by a perpendicular line and one angle is marked as 90 degrees. We need to find out the measure of angle A when one of the angles given is 67 degrees. Question number 3. In the figures below, what angles do X and Y stand for? In figure 5.32, we have two images. In the first one, two lines are parallel which are cut by two transversals. One transversal is perpendicular and another one is intersecting this perpendicular transversal. And we need to find out angle X and angle Y when one of the angles is 65 degrees and the other one is 90 degrees. In the next image, we have set of parallel lines cut by two intersecting transversals with angles marked as 53 degrees and 78 degrees. We need to find here the angle between the two transversals. Question number 4. In figure 5.33, angle ABC is equal to 45 degrees and angle IKJ is equal to 78 degrees. Find angles angle GEH, angle HEF angle FED. Here we have figure 5.33 in which pair of parallel lines is cut by two intersecting transversals and the angles IKJ is equal to 78 degrees, angle ABC is equal to 45 degrees, and we need to find out the angles angle GEH, angle HEF and angle FED. Page number 125. Question number 5. In figure 5.34, AB is parallel to CD and CD is parallel to EF. Also, EA is perpendicular to AB. If angle BEF is equal to 55 degrees, find the values of X and Y. Here, in figure 5.34, we have parallel lines, three parallel lines, namely AB, CD and EF. We also have angle BEF as 55 degrees. We need to find angle X and Y. Question number 6. What is the measure of angle NOP in figure 5.35? In this picture, we have lines LM parallel to PQ and we have some intersecting lines as MN, NO and OP. Angle LMN is marked as 40 degrees, angle MNO is 96 degrees, angle NOP as 8 degrees and angle OPQ as 52 degrees. We need to find out the measure of angle A. Hint provided here is draw lines parallel to LM and PQ through points N and O. 5.9 Parallel illusions. There do not seem to be any parallel lines here. Or are there? Here we have three different images which create illusion of parallel lines, though they are not parallel. The lines are parallel if you observe them very carefully, but they create only an illusion of parallel lines. What causes these illusions? Page number 126. Summary. First point. When two lines intersect, they form four angles. The vertically opposite angles are equal and the linear pairs add up to 180 degrees. Second point. When two lines intersect and the angles formed are 90 degrees, that is, all four angles are equal, the lines are said to be perpendicular to each other. Third point. When two lines never intersect on a plane, they are called parallel lines. Fourth point. When a line T intersects another pair of lines, it is called a transversal and it forms two sets of four angles. Each of the four angles in the first set has a corresponding angle in the second set. Fifth point. When a transversal intersects a pair of parallel lines, the corresponding angles are equal. When a transversal intersects a pair of lines and the corresponding angles are equal, then the pair of lines are parallel. Sixth point. When a transversal intersects a pair of parallel lines, the alternate angles are equal. Seventh point. The interior angles on the same side formed by a transversal intersecting a pair of parallel lines always adds up to 180 degrees. Chapter 5 ends here.
Ganit Prakash, you were just listening to this audiobook, Textbook of Mathematics for Grade 7. Narration Swarnlata Sharma. Sound recordist Prasoon Kumar. Production assistant Soumya Malik. Directed and produced by Vimalesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.